Okay. Sketch a graph of r equals 5 cosine of 3 theta plus 1. Oh my gosh. I don't even know what this is going to look like. I just made this up. I was going to have us do a lemicon. I was going to have us do a rose. Then I just was like, forget it. I'm going to make it pretty. The way we're going to do this is by plotting a whole mess of points. Again, the coordinates of a point are r comma theta, but for us, it's easier if you do the theta first, and then from that, do the r. But when you plot it, again, it's r comma theta. What we're going to do is we can use either radians or degrees. I'm going to suggest degrees. It's a little bit easier. And we're going to plot every 15 degrees. So, 0 degrees, 15 degrees. Oh my gosh, what's going on? That's not good. All right, those should be little degree symbols. I'm sorry about that. Well, the thing is, to make your life a little bit easier, what we're going to do is we're going to pretty much have the calculator do it for us. And I'm not even to 90, and I'm already out of room. That's awesome. Ugh. So you would go from 0 to 360 on your papers. So hopefully that's what you did. But I'm going to show you how to do all this on your calculator. So let me load up mine real quick. By the way, you will also get to do this on your test. The good news is I'm not going to have you go from 0 to 360. That takes way too long. Small. All right. Close you. So if you would, whip out your calculators. We're going to go to a brand new mode. Huzzah. If you hit your mode key, mine is already set up for this because I'm just that awesome. The third line down, or fourth line actually, functions. Par means parametric. Next is polar. Make sure polar is selected, P-O-L. Oh, look at that, S-E-Q. I wonder what that means. Not for this class. Please make sure polar is selected. Once you are there, you're now going to hit y equals, and you're going to see something amazing. It doesn't say y equals anymore. What does it say? R equals. Look at that. I need you to type in r cosine of 3 theta plus 1. Your theta is the same button as your x. And I forgot to mention, while you are in mode, make sure we are in degree mode because all of our angles are in degrees. One more time. What now? Oh, no, that's something else. All right, so in your r equals, which is your former y equals, you have your 5 cosine 3 theta plus 1. And then in your mode, you should be in polar mode and also degree mode. What we're going to do is we're going to have the calculator generate a table for us. So go to second table set. Notice we're starting at 0 degrees. So make sure your table start at 0. And your delta table is how often we are adding to get to the next, what we're adding to get to the next one. So what do we keep adding? How many degrees? 15. Since we want the calculator to automatically make the table for us, make sure independent and dependent are both on auto. Now, to be honest with you, you didn't really have to write 360 because 360 should be the same answer as 0 because they're coterminal. So we're really only going from 0 to 3, what is that, 45? Yeah. And then if you go to second table, there's your table. Now mine's a little gunky. I'm going to make the size a little bit bigger. Bam! So for me, all I care about is, on your test, fill in the numbers that I give you, go into your calculator, get the decimal equivalents. I'll tell you how far to round. However, if you're able to differentiate on your paper the difference between 4.50 and 4.5355, you're totally in the wrong class. And you have way too much free time. So I'd probably just say 1 decimal place. So 4.5. I'm cool with that. And then what you're going to do is just plot each one. So your first one would be along the positive x-axis because that's theta equals 0. You're going to go out 6 units. And then the next axis above that, so this right here would be your 15-degree line. So at 15 degrees, you're going to go out 4.5 units. And notice pretty soon we get into some negative values. So you're going to go in this direction, but then go opposite. Okay? So we're out of time, but for Thursday, try to plot this on your own. Oh, how many points that is, I don't even know. 18, 24, 36, hut. Oh. Previously in math class, the class was asked to graph the entire thing. Since I have a fantastic honors class, I am excited to realize that no one graphed the entire thing. So let's continue where we left off. All right, class. No, this is recorded for all of time. So everyone will know. I'm going to use my Google glasses now to take a photo of the class. All right. Photo taken. We're going to capture a selection. Ooh. Bam! Where's it at? There it is! As stated before, the theta is the angle measurement. The radius is how far you go out in that angle measurement. Unless it's negative, you go in the opposite direction. So we already looked at what it would, the end result would be, the flowery-like picture. So just doing a couple of these. Hey, look at that. The first point we can't even plot because it's way off the graph. Oh, well, it's supposed to be somewhere over here, I'm sure. So that's 6 for all intents and purposes. And then the angles are at 15-degree increments. So 4.5 on 15 degrees would be right about there. 30 degrees, 1. It comes in really far. And then 45 degrees, negative 2.5 in the opposite direction. So 1, 2.5. And then negative 4 at 60. And then negative 2.5 again. And then positive 1. Now, it may be beneficial to sketch this in as you go as far as connect the dots. So far we should have something that looks like that. Now, yeah, there's a little guessing going on and a little bit of cheating because nowhere in there did we go through the origin or see an actual point at the origin. So you would have to cheat and look at the final result graph to know that it's going to go through the origin. The other thing you could do is plot a bunch more points. But instead of counting by 15s, you probably have to count by 5s to see that you would get a 0, 0 eventually. Or a 0 for the radius, excuse me, eventually. So not the prettiest thing, but it will get the job done. But on the test, what I'll have happen is I'll only have you graph a portion of it because it takes time to set up the table, plot all the points, connect the dots, yada, yada. So I might either have half the graph done for you or probably even 3/4 done and you just do the remaining quarter. Okay? All right. So again, it should have that, whatever that shape was. Let me see if I can get it back up here real quick. Ah, pretty. So it should look like that when you're all done. But probably not at an 8-bit photo. You're welcome.